Good morning, everybody. I'm John Zilovakis, and myself and my colleague Doug, who's on the other side of the room, and we're going to run you through the Farmland Ecosystem Assessment Support Tool, FEAST for short. That's an output from the Framework H2020 project. The rough schedule. This is the broad schedule we're roughly going to stick to. It's fairly flexible. So I'm going to start off with welcome and introduction, and I'm going to run you through the general concept that lies behind the FEAST tool, then outline some of its key functions, and just do a quick overview demonstration of it just to give you an idea of what it does. Then we're going to go into a set of examples. Hopefully we'll get through all four that are drawn from the framework cluster network, so some real life examples. And we certainly would like to invite questions during those examples, be it on any aspect, be it on the ecological aspects or just on the functionality of the tool, what have you. We really would like that to be quite an interactive process, so don't be afraid to ask any questions as we're going through those examples. We would welcome that. And then at the end, we've then got hopefully maybe 20 minutes, half an hour for a general Q&A and a bit of a panel discussion. So let's crack on into an overview of FEAST. So we're going to start off here. This is an agricultural landscape, as you can see. This is a farm that's just down in Kent, just southeast of London, Ranscombe Farm. And the FEAST software operates on a process on which many environmental management decisions are based on, this sort of cycle of continuous improvement, effects and impacts. And we can overlay on that various sort of management processes. So we've got performance and diagnosis, options appraisal, action plans, and observation and indicators. So the idea being, obviously, you take various data from here, feed that into your system over here to be able to work out strengths and weaknesses in the landscape, diagnose issues, combine that with knowledge and expertise to come up with solutions for a range of different options, and then implement those with actions, with various guidances to support that, and hopefully that has the desired impact. So we'll run through that. We can start anywhere on this cycle. We're going to start with observation and indicators. And first of all, the key thing we're interested in here is obviously biodiversity and wildlife species populations. There's various information that we can... Somebody keeps coming unmuted and making a lot of noise. Can you make sure you're all muted, please? So first of all, we can gather information on actual species observations from a variety of sources. We can draw in information that's in GBIF, the Global Biodiversity Information Facility. You can make species observations yourself and using tools like iNaturalist to aid identification. Or, of course, we can employ more scientific processes to collect data more systematically, be that things like pan traps, cameras, and other means to actually systematically observe wildlife species populations. When we get that data, we can bring that into FEAST and we can use it within the tool, and I shall show some examples of that later on. Of course, we've got a whole range of other data that we can draw upon. We've got various land use, land cover data. We will have information on various agronomic and cropping practices that are going on, what crops are being grown. We've got various information on landscape features, be it woodlands, hedgerows, wildlife strips, field margins and so forth. And so we can gather that information as well. And that's really quite crucial information, especially on terms of understanding the sort of actions that are being taken on the ground to try and diagnose particular problems. If there are certain species that aren't thriving in the landscape, we can look at the data attached to all these landscape elements to try and work out what's going on and what the issues might be. So we end up with a lot of data. And that might be qualitative data, it might be quantitative data. It's then a question, how do we then use this data to actually make some assessment of this landscape to try and help us manage it? That's where we slip over from observation indicators into performance and diagnosis. And we can use that data within the FEAST tool to do a number of assessments and calculations. We can do calculations on habitat suitability, which will take account of habitat complementation. Is it meeting all the needs of each species? We can account for agricultural pressure. We can take account of landscape configuration, both in terms of connectivity and also sort of zones of influence for particular species. And we can also do calculations of ecosystem services. This allows us to essentially then, by doing these calculations, identify various strengths and weaknesses in the landscape. Where are the hotspots where things seem to be going well? Where are the weaknesses where we know perhaps there need to be improvements made? And then with the latter, it's then a question, what actions could we implement to address those weaknesses? And that's where we then step into options appraisal. And there's a number of different things we could explore depending on what the previous analysis actually highlights. It might be that we need to improve habitat suitability for a particular species. We might need to reduce the pressure from agricultural activities. We might need to create space. We might need to create new habitats. Or we may need to make sure the habitats that are there, if they make sure they're better connected, to try and reduce the fragmentation in the landscape. So we can pick a rather obvious example just to illustrate that. So you can see here, this little block of woodland on the right-hand side is this one on the map here, and it's quite isolated in terms of not being connected to the other bits of woodland in the surrounding landscape. So we might establish, because of that, that actually this disconnection is causing a bit of a problem for some species in terms of how valuable this little block of woodland is on its own here. So we might want to explore a sort of what if scenario about what if we maybe created a hedgerow to try and make it better connected. And so within the FEAST tool, we can say, well, let's put a new hedgerow in and do another calculation, see what difference it makes and see how it improves the connectivity in the landscape and what impact that might have on habitat suitability for a particular species. If we then decide that actually that seems like a viable option, we can then do a bit of signposting, which is when we start to step into sort of action plans, and we can steer people towards relevant resources online, in this case maybe about hedges or hedgerow restoration, to give them a bit more information about how they would actually go about implementing some of the issues and some of the options that I've identified in the previous analysis. So that then takes us full circle, because once we've implemented something in the landscape, we want to know, has it had the desired effect? Has it actually improved the habitat suitability? So we've done this process of understanding strengths and weaknesses, raised a few options, implemented them. We now want to know, has it had the effect? And so we then hopefully will be able to see some sort of response in species populations. Now, of course, for some species that may take quite a bit of time, but by providing a facility within the tool to actually make those observations and actually record them over time, we can start to see if there is any improvements in terms of how things are changing. So bring us onto the actual software tool itself. We can do various functions within the tool. So there's various calculations and assessments that might have habitat suitability, accounting for complementation, connectivity, and we can also calculate ecosystem services. We can graphically visualize the data. As you'll see, it has a mapping interface, so we can put everything on a map, and that might be the monitoring data. It could be various land use activities, optimal zones that we can identify. We can combine and overlay data, so we can take our habitat suitability assessment, overlay it with monitoring data. And then we got various options, appraisal and signposting functions, so we can explore what if scenarios, and then we can direct to guidance that's relevant, as just mentioned earlier. Now, first of all, of course, when you're doing anything in the landscape, you need to know what is it you're aiming to do. Every farm is different. Every farm will have its own particular priorities and objectives. And we'll see some of those in some of the examples we'll explore later on. We've been building up everything in the tool over the last 5 years. So we now have about 66 indicated species and species groups within the tool, covering a whole range of taxa. As you can see some of them with the icons on the screen there. We also have 25 ecosystem service indicators in there. Overall, there's well over 500 metrics. Once you start breaking down particular species and their requirements, the individual metrics, which are those, you get quite a few things that are being calculated. And we've got all those metrics for about 23 different landscape features and land uses, which covers the majority of European farming systems. There's probably still a few that we don't cover, maybe things like rice, for instance. But these are things that we hope to build on and add as time goes on. And you'll find once you pick a few, we can then explore those. And I've just highlighted some of these, which we're going to explore within the actual case studies themselves. So this takes me to the first little demo that I'm going to do. I'm just going to show you some of the functions live and then before we go into the case studies. The tool itself is a Windows-based application. So you download it and install it on a computer locally. We, by and large, think that the primary user group are things like cluster facilitators or advisory organisations, those giving out advice on the ground, but potentially individual farmers, if they're really interested, could use it. Other researchers, even potentially policymakers exploring what if functionality could also use it. But sort of those advising on the ground is really what is our target audience, I think, really. It's all freely available online. You can access it by the QR code or the URL there, and you can download it without having to register or anything like that. Now I'm going to switch over to the tool itself, and so hopefully it will let me do that. Okay. Is that showing up okay, Doug? Yep. Cool. I'm going to, as I say, this initial one's to show you what the tool looks like and some of the functions within it. You can see here on the overview, it shows that cycle of continuous improvement and overlays some of the functions that I'm going to show you within that framework that we were shown in the slides a minute ago. I'm going to open up one from that Ranscombe farm that I was shown on the slides there. It loads up the project, which contains a number of files, data files, and also mapping files associated with it. We can start anywhere. As I said, biodiversity monitoring data is one place to start. If I open up this particular interface here, we've got a map, and this is the data that we've got for biodiversity monitoring for Ranscombe. I've downloaded this from GBIF, so it's not systematically collected data. It's everything that's been recorded by anybody who's done some observations on Ranscombe, but we can start going through and selecting things. I click on birds, there's probably quite a few thousand of those. It shows those are listed and we can display them on the map. Should have picked a smaller group to start with, but it's loading them up. It's putting up about 6,000 observations onto the map now. Here we can see in the area we were looking at, this is showing all the various observations on the map. And if I click on any one of those, it will show them down the list there. And we can, there's various links off. If I clicked on that, you can see it's got the GBIF record for, in this case, the goldfinch. It's got those links in there. So it gives you an idea that you can display any of the information in here on a map. We can, of course, do something a little bit more sophisticated. If I clear the map and say, let's pick something that we're going to look at later on. So I'm going to have a look at a particular butterfly group. There we go. In this case, we got about 3,000 records. We can plot those on the map again. We can see again, these are particular butterfly observations in that group. And we can start to see the statistics behind that as well. If we come over to here, we can put on the number of observations. Drag that up. So you can see that better. Going right back to quite a long time ago, right up to current day, we've got a range of different observations for this group. As I said, this is not systematically collected data, so it is observations. To try and make it more meaningful, you can express it as part of a group. If I click that option on and say, let's express it as a proportion of all Lepidoptera. We come down to second chart. Now this is showing the percent of all observations of Lepidoptera that are particular in this group of Nymphalidae on the group there. You can see it's up and down, which we know with butterflies, they're very volatile in terms of their observations, but we can see a trend over time. Equally, we might be interested in something completely different. And so I clear that and then come back to a simple search. Let's just say we're interested in skylarks. Then we can put those on a map. We can see all our skylark observations, and similarly we can plot a chart to do the same again. In this case, I'll do observations. You can see there's a large peak in 2021 and a drop off after that. Again, as this is observations by members of the public, it could well have been due to people out walking in the countryside during COVID, boosting the number of observations. But it shows we've got the data in there and you can manipulate that in different ways. What we can also do, of course, is do assessments. Without going to the mapping interface first, here's all our different features that are in that landscape, and we can pick any one of these. I'll pick the block of woodland there, woodland 1. You obviously describe, you enter the data in the top half here. We say it's broadleaf woodland, mainly native, some moderate open space and so forth. And based on the data and the attributes of that woodland, it then does various calculations. And if I narrow that down, there's a few icons to start with, we can see it's done. The indicators we picked here, we've got brown long-eared bats. We've also got, I think it's probably long-tongued bumblebees. This is the overall assessment, but you can see the breakdown for individual components of the life cycles. We've got the forage, we've got hibernation, and we've got maternity roosts for the different bats there. You can show the different performance of that feature in relation to that particular species. That allows us to do calculations of individual features. But of course, when it comes to the landscape, we want to do something a little bit more sophisticated. We can, within the mapping interface, we load that up. This is the area we've assessed here. I've used a blue color, and so darker the blue, the higher the performance. We can zoom in. Let's put up the metrics tabs. Let me change the options on that. The first thing it does is see if everything in the landscape that is needed for the brown long-eared bat is there. And then if it is, you can then do a calculation. And then it shows you that on the map there. If I then pick a different species, maybe curled buntings, I can then display those on the map. Similarly, we've got different highs and lows, different strengths and weaknesses in the landscape for there. I'm not running the calculations in this instance. I'm running through to show the variation. Similarly, linnets, we can put those on. We can do calculations and we can see how it is on the map. We also get a report down here which shows there's areas of land that are meeting different requirements for forage and nesting and overwintering. In this case here, links to guidance and so forth, and what's needed in terms of attributes, those features to address any weaknesses. And I'll come back to that when we do the case studies in a bit more detail. It also picks up when there have been observations of that species, and you can load those onto the map. We can see this is everywhere linnets have been observed on the map. So we can see how that matches up with habitat suitability. And we can also try to identify optimal zones, taking account of what's been provided in the landscape. If I go back to the brown long-eared bat for that. And first of all, I'm going to say don't account for barriers. We only need 3 habitats instances identified given the range of the species that this is one big optimal zone here. However, as you probably spotted, There's quite a major road going through there, and also linked to the Eurostar goes by there as well. If I remove that, providing you've defined various barriers like roads and railways on your map, what you can do instead and say, yes, account for barriers. In this case, it says on this side you're okay, but it's likely, given that the brown longyearbak doesn't like motorways or lighted motorways in particular, it's unlikely to venture off on that side, especially into urban areas and what have you. We can take account of barriers in the landscape when it comes to doing the habitat suitability and optimal zone calculations within the tool, which can be quite useful for a number of things, but also in terms of understanding the strengths and weaknesses. It's no good if you say you've got 2 out of 3 habitats on this side and 1 on that side. You're going to have a bit of an issue in terms of suitability. It all needs to be within a certain range without anything blocking movement through the landscape. I think that's given you quite a quick and broad overview. The best thing to do is go and explore some real examples. We'll come out of here for now, and we'll flip back to the presentation. Let me do that. Let's come up okay. We've got 4 case studies that we're going to run through with you. We've got a detailed one in the Czech Republic, which we ran a webinar last week with a cluster there focusing on grey partridges. We've got another one in Luxembourg, and then another one in the Netherlands, and then a smaller one highlighting something different down in the south of France. Let's press on with those. This first one is an organic farm in the southeast of the Czech Republic. They've, in the last number of years, been trying to reintroduce grey partridges into the landscape, but it's failed. It hasn't worked. They've all died. Hence, they were really interested to see if they can use FEAST to try and identify where maybe the weaknesses are, do an assessment of the habitat suitability to see if that will help steer them in what they might do next. And talking to them last week, and they gave us some really quite useful feedback, especially some of the ornithological experts, on other things that we might use to refine the habitat suitability assessment within FEAST. That's really good. We recognise that this is not a static system. We got new knowledge that we can add in all the time and refine the tool to make it as good as we can. So we're really keen to make sure we get as much feedback and we can improve it as time goes. I'm going to explore this case study. I'm going to hand over to Doug to explain a little bit more about the grey partridge and its particular needs, because he's a bit more expert on that than I am. And then we'll do a demo once he's explained that. Over to you, Doug.
Thanks a lot, John. As John's been saying, we're going to look at the grey partridge. The way the habitat suitability indices work is it's based on a methodology used in planning and development applications in the UK. Assigns an index between 0 and 1, depending on how suitable the habitat is, 0 being unsuitable, 1 being optimal habitat. 0.5, suboptimal, it can use it, but it's not ideal. For each of the different land uses, John's given some examples, and for each individual species, we'll assign one of those scores to a given type of land use or a given type of land management. We also have to bear in mind species life cycle on a temporal basis, so it's got to be able to complete its life cycle through, and we've allocated these particular classifications here: nesting, forage, and overwintering, so suitable food over the winter. And depending on the species, these have to be within a given distance, what we call the core sustenance zone. And that depends on the mobility of a particular species. For the grey partridge, ideally within about 800 metres of each other. Forage, again, that can be allocated to the adult or it can be allocated to the young, depending on the species in particular. I'll give an example of that. The next slide, please, John. Nesting. Ideally what it will have is grass margins, beetle banks, so tussocky grasses that provide plenty of cover. We're looking at a spatial element here, so you might notice that the FEAST tool has that aspect to it. Ideally, if you have these grass margins or these grass areas, they're in central field areas, not connected to boundaries. They're not linking in with boundaries that might be used as corridors by predators, for example, foxes. Or they can be wide sown grass strips. They may be on the edge of a field, but because they're wide, in excess of 6 metres, there's potential for the nest to be on the edge opposite to the boundary, so they don't get detected by predators so much. These are what we call optimal nesting habitats. They'll be assigned a score of 1. Can also utilise very short but thick, wide hedgerows where they can get right in at the base, and that provides some protection from predators, ideally a limited number of trees to prevent perches from, for example, raptors. Suboptimal habitat, potentially winter cereals when there's no other alternative exists, but this often will be on the edge of a crop, and that renders the nests exposed more widely to predation. So we have different habitats within the tools that can be selected and can be placed spatially within the landscape, and each of those has a particular habitat suitability for that aspect of the grey partridge life cycle. Next slide, please, John. The forage, at the moment, the focus is on the chick stage, is on the chick. The chick itself is very weak when it first leaves the nest. It's unable to move through dense vegetation, i.e. the vegetation that's suitable for the nest site. It has to effectively leave the nest site or the grass margins. And these need to be where it forages, something like weedy cereals, something where, for example, there's what we call a conservation headland or a low input cereal where there's, say, no fertilizers or there's a reduced seed rate, no herbicides, so there's plenty of seeds and insects available. Or it can be, for example, unharvested crop. But what that does is it provides tall cover to prevent detection from predators, but it's low density at the base. So that means that the chick itself can move freely through it without the barriers there. But this, because they are not so mobile when they first leave the nest, has to be very close to the nest site. You need these two habitats close together within the landscape. Pollinator mixture can provide some cover. Again, that's another example of a potential forage area. But ideally, these thin, weedy cereals, and these could be available through, for example, agri-environment schemes, but it needs to be close to the nest site. The next slide, please, John. And then overwintering, ideally what we're looking for is something that provides seeds, something with high calorific value to get them through the winter, in combination with the provision of winter cover. These can be, for example, materials that can be available for agri-environment schemes, wild birdseed mixtures, overwinter stubbles. There's certain particular crops that may be more beneficial, but these have to be where there's natural regeneration. Sterile is of no value. They need to have not been treated with any form of herbicide so that you've got natural regeneration of weeds that are then going to provide seeds. And you can also supplement those with additional seeds. That's an agri-environment scheme. There are other options available, things like fodder crops, for example, turnip radish, if they're left for a long time before they're being grazed. And there is also the option to supplementary feed with grain. That's not currently available in feast. That's something we're potentially looking at. These optimal habitats, score of 1. But those three, so the nesting, the forage and the overwintering, need to be within sufficient spatial proximity to each other within a given area to supply all the requirements for the grey partridge to complete its life cycle. Next slide, please, John.
Back to me. Let me flip back into the software and open up the check one. Let's open up the mapping interface. This is the Eco Farmer Probio. It's, as I said, down in the southeast. If I click that off for the moment, this is the area here, covering a relatively small area in this instance. It's an organic farm, largely arable. And as I said, they wanted to introduce grey partridges, but after they attempted to do so, it didn't work. They didn't survive. And they didn't really understand why. It's an organic farm, doing lots of different things in terms of trying to encourage environmental improvements, but they didn't understand why the grey partridge wasn't a success. However, if we flip open the spatial metric tool, we got our grey partridge assessment here. As I said, the very first thing it does is say, well, has it got everything in this landscape? And the answer is no. it's fundamentally missing any overwintering habitat. And that in itself was a bit of a revelation to them. It's something they hadn't thought about. And so if we then come down to the report, and what I'll do to make this a little easier to see, we can put that to a browser to see it a bit better. Let's come up. The actual report itself tells you the things that we're looking for in terms of relevant features. But if we come down here, we can see that there's various things being suggested for forager nesting, but we're interested in what's missing from an overwintering point of view. Now, it could be, in this instance, it's suggesting various land blocks and strips and margins, that some of those which Doug has been talking about, but also the arable land itself, in particular, things like winter stubbles, if they're being used at all, which provides that habitat over the wintering period. This is where we can also provide signposting and links to further information. If you wanted to know more about the wild bird zone mix, if you click on that link there, it will take you off to, in this case, a page all about that particular management and how and so forth, various information. Likewise, for winter stubbles, we're guiding people to relevant information that's available to help them understand more about that particular option. It's given us a number of ideas to explore here, so let's close that for now. Let's now think about, we've diagnosed as a bit of a weakness in the landscape there, so now we can go into that what if scenario phase. What I'll do is actually pick one of the arable fields. I'm going to pick this one here. Before I do that, I forgot that we can say actually where should we actually locate some of these potential options. We can use that optimal zone assessment that I showed briefly earlier to show where the existing habitats are. And in this instance, we can see actually most of the farm, we've got the two habitats already. We've already got nesting and forage available, so that's good. We need to be doing something in that zone. Let's switch that off for now. Then we can come in. I've already picked this arable land block here. And then I'm going to come to the feature data, and just as you saw earlier, I'll select it again. It will then give me the input data fields to edit. Here we go. We've got a number of things we could change. In this case, I'm going to change it, the winter stubble option. I'm going to change it to cereal stubble with enhanced seed mix. We'll use the first one there, and I'm going to save that. What we should now find, it will now do this initial assessment to see what's available. And now we're ticking all three of the boxes that we need. We're starting to unlock the landscape. Now, what we should be able to now see, if I actually come over to here and look at the categorization, if we put on things like where the forage is, we can see that on the map. We've got a bit down here, a few little strips through here as well. Similarly, we can put on the nesting. We've got quite a bit of nesting habitat distributed around, and we've now actually got some overwintering available by that block there. But what we can do now, we can do a full calculation because we're ticking all the boxes to see how well that landscape is working. I'll quickly do that, and it will crunch some numbers now. What it's doing now is looking at where all those different features are, the relative attributes of them in relation to nesting, forage and overwintering, working out how far apart they are. Oh, always get a bug when you're doing a live demonstration. It's doing the calculations with throwing up error messages, of course, for me to look at later, and seeing how well they're connected, and using a number of different algorithms to do that. It's then done an assessment based on both the landscape configuration and the complementarity of those three different habitats that we need. And we can see if I put the key on, numbers are very low because it's scored 0 to 100, but we got a range, and you can see the various areas of those different bracketed numbers up there, generally towards the lower end because we've only put in a little bit, so darker colours are quite missing in the landscape in many respects. But we can then start to see actually we've started to address some of the weaknesses on the western side, but we haven't got anything going on down in the southeast here at all. It may well be that we need to actually do some changes down here as well. It could be, let's do a few things to a few different features. Let's close that so we can see what we're doing. I'm going to put winter stubbles on here. We'll do the same there. Save that. Then I'm going to pick something in the middle here and do something differently. So we'll pick that strip along there. And I'm going to put a conservation headland on that field, something different. That will provide forage for the partridge as well. So we've made those changes. Let's do a recalculation and see what difference that makes to the landscape. You can see it's got the progress chugging away down here. It's relatively quick for a small landscape. So we've now got more showing up here, which I'll show you once that closes. So we're starting by making a couple of changes. We're starting to utilize some of the existing habitats that were there for nesting and forage, but we've added a few extras, and we're starting to get steadily an increase in habitat suitability. So if I put the key up, we can see the numbers are steadily going upwards, and we're getting a greater spread as well. So it's slowly but surely trying to understand where the weaknesses are by making some changes. And we were having discussions with some of the advisors on the ground last week, and they were asking questions about, I grow a lot of buckwheat, and can we leave that as stubble over the winter? And so that's something we're going to look at. We don't necessarily have that in our list at the moment, but that's something that might be useful to get in the system for another type of cropping that we've got in the landscape. So that shows you the general process for understanding the weaknesses, exploring a few options and what the impacts of that are likely to be. So we'll flip out back to the presentation now. There are, of course, a number of other factors, and Doug, perhaps you'd like to run over those.
Sure. Thanks, John. Okay. I did mention earlier about the trees in the hedgerows. So when certain phases of the life cycle, they can be more vulnerable to higher levels of predation. Game and Wildlife Conservation Trust in the UK, studies conducted by them have been mainly by sparrowhawks sitting on perches, raptor perches as they're called. So these are trees in hedgerows, for example, or by foxes that are typically moving along the field boundaries. So that's why ideally you would have a habitat to attract partridges away from the boundary features if you can, or away from areas where there is lookout posts for predators. Provision of tall vegetation, susky grass in the early spring when these are most vulnerable to predation, for example. So these will be looking into just before nesting. So this is the overwintering area starting to shift into nesting periods. So tusky grass areas where you can get down. Beetle banks, for example, would be an ideal. There is also the option of predator control. This isn't something covered in Feast. GWCT has its own tool that has a lot of information on that. The link is there if you're interested in that one. We'll focus more on the habitat suitability side of things and be linking it all together throughout the course of the life cycle. There is also another aspect in terms of the type of adult if they are artificially released. So if you translocate wild birds, they tend to have much higher survival rates compared to, for example, birds that are reared in captivity. And then there is a hierarchy of rearing, for example, parent-reared birds, bantam-reared birds, or artificially reared birds, for example, in an incubator. Generally speaking, there's a decline in survival rates. That's not something that's taken into account in Feast, but that would be something that, outside of using the tool, whoever's interested would need to take into consideration. And there's some interesting information there. For example, GWCT has that information, and there's a link down there. Okay, next slide, please, John. Something that can potentially be, there's always improvements to be made. This is something that we're looking into, is distance from the boundaries. I mentioned about the spatial aspect and creating suitable habitat in more central crop areas. So we're looking at refining that and how we can take into account potentially the increase in predator risk at certain phases of the life cycle. Also, the focus of the forage is the chicks, partly due to they are the weak points in the life cycle, their inability to move too far from the nesting site. We're looking into developing a separate index for adults only during the spring and summer. In terms of distance from suitable nesting habitat, potentially, as mentioned before, it needs to be close by. Again, potential to set this in different distances. We're looking into the options to do that. It's using a default being adjacent habitat at the moment, but there's potential to look into different distances depending on how easy the landscape is to move in. And something that came out of the presentation to the Czech cluster last week is the use of biobelts, which is being used in Ireland as something another type of land use we currently don't have in fees, but it's something that is of interest. So if anyone has any suggestions on particular land use types that might be relevant, please do let us know. Also, field size and spatial dimensions, something that's potentially being looked at on the Czech Eco Farmer case study. Okay, next slide, please, John.
Just put that. I think that's the end of that particular case study. I was going to say, I'm going to invite if there's any particular or very specific questions for that case study before we move on to the next one. Do please shout out now. If not, we'll press on. Can't see any raised hands. Okay, we can always come back at the end and answer any specific questions that come up related to grey partridges or how it's integrated in the tool. So let's move on to something a little bit different, from grey partridges to hoverflies. So we're moving slightly westwards from Czech Republic to Luxembourg. So this next example is showing how, firstly, hoverflies, the model we got for that, which is quite a sophisticated model, which Doug will explain in a minute, but not just in terms of how that's implemented within the tool, but I'm going to demonstrate how sometimes you can be looking at a whole map or bigger landscape and there'll be strengths and weaknesses in there, somewhere it is being met and another half where it isn't. And I'm going to show you how you can use the tool to differentiate the two and explore what if scenarios in that. In this case, we're looking at the Bourne case study in the east of Luxembourg, and it's a landscape that's got a mix of very traditional orchards. There's some very nice cider that's made there. But it's also got arable land, grassland, hedgerows, scrub, and woodland all in the mix as well. So we'll see some of that in the middle in a minute. As I said, the habitat suitability assessment for hoverflies is a beautiful model that's been developed by Paul van Rijn and Laura Manser at the University of Amsterdam, and it's been further advanced within the framework project. And I'll let Doug explain a little bit more about that now.
Thanks, John. So the graphic that you see in front of you is courtesy of Laura Manser. She's been doing a PhD on this. So what we can see is we've got thinking back to the grey partridge, so we've got this overwintering habitat that's required. There's the requirement for successful reproduction, and there's a requirement for forage, either through the young or the adults themselves. So if we go down to H1 on Laura's habitat model, so this is effectively overwintering habitat. So this is subclimax vegetation, it's hedgerows and scrubland. It's where adults can shelter, possibly in leaves at the base of the hedgerow. When they emerge, or early on in the season, the adults will need to feed. So if you notice the arrow heading to the bottom right-hand corner, you notice there's a flower and there's also a pollen grain. Flower proposes, the flower itself is representing nectar. That is required by both males and females. It powers flight, powers movement, dispersal. Pollen will be required by the females for egg production. Hoverflies, they have quite large eyes, quite large heads. There's certain flowers they can't use. Those with narrow, deep corolla are of no value to them. So they have to be quite broad, open flowers, particularly families of the daisies, for example. You may not at that stage in the season have too many examples of those in flower, but there are other alternatives. So things like willow, for example, present in a hedgerow, or birch, for example. Flowers are suitable and they are present quite early on in the season, so maybe from late February through into March. So it's ideal times. It's a good species to have at that time. They'll lay eggs. They will be, for example, the larvae will hatch. The larvae are predatory and they will consume aphids in the scrub hedgerow habitat.
The dispersal range from the overwintering site to crops or habitats tends to be higher at this stage in the season. So could probably be looking at up to 1 kilometre around that time. As you progress into the next phase of the life cycle, so H2, so this is where we've got adults laying eggs, females laying eggs, and in the edge of the crop itself. But what they need, obviously, is they need the nectar, and the females need the pollen. They need to consume that. So if you look on the H2, there's a flower graphic. So this needs to be in close proximity to where the aphids are going to be. So this is, we're looking at it from a potential IPM perspective. So this is the concept of having a wild flower margin close to the edge of the crop. Dispersal tends to decrease at this point. You're looking probably about 50 metres for the female moving in to find a suitable egg-laying site. So wildflower margin, edge of the crop, can then move into the edge of the crop, lay the eggs, larvae hatch, and they will start to consume your pest aphid within the crop itself. What they need to be using at this phase is early developing crops. So these would typically be winter crops, according to the model. And then H3, again, we're looking at a similar process, but this would be looking at later developing crops, so probably your spring sown crops. For example, spring sown cereals or things like potatoes. But again, needs a wildflower margin close to the crop, sustain the females and egg production, and then the crop itself will sustain the larvae. Okay, next slide, please, John. So within Feast, we've got, whereas we had the 3 life cycle components with the grey partridge, we've now got 10 life cycle components, which count for each of the processes I've just mentioned, based on Paul and Laura's habitat complementarity model for hoverflies. So we go through overwintering, and we're looking at adult forage at 3 key times of the year, so early spring, late spring, early summer, and then during the summer itself. And again, provision of suitable forage for the larvae. So all of this, you need these 10 components in order for this particular group of individuals to complete their life cycle throughout the season. So it's a little bit more complicated than the previous example. Okay, next slide, please, John.
Okay, so that's back to me again. So we're now going to explore that particular model within the Bourne cluster landscape. So let me flip back. So we'll jump out of our grey partridge example, and we'll load up the Bourne cluster. So let's just go straight into the mapping tool. Okay, there we go. So we're interested in, this is the block that we've got mapped out here with the blue lines. The yellow dots are showing where the different observations have been made, in this case specifically for hoverflies. So if I come on to here, we can see some of the hoverflies, in this case the Cifridae, that have been observed in these different locations. So we've already done, as I showed earlier, we've already created a map with the observations on it, and we've got a map here with all the different land uses and landscape features. Now, if I turn on the spatial metric, and we'll then see our assessment for hoverflies. As we see, we can see the 10 that Doug mentioned, and in this case, they're all present in the landscape, which is good. However, if we click on and put the optimal zones on, what we find is once it essentially overlays all the different habitats and sees how many are there, are actually where we get all 10 is actually just this area here with a mix of various combinations, be it 1, 2, 3 or 4 or 5 in some locations, but actually where all 10 occur are here. And if I just tidy that up, you can actually do the place where all 10 are on the map, and we can see that a bit clearer. So reload the assessment. Once my machine catches up. So if we do that one instead, you end up with a slightly cleaner map to look at. So quite nicely, of course, we can see actually the hotspot on the map seems to be aligning with where some of the observations have been made. In this case, the observations do actually include some of those that have been more systematically collected by LIST in Luxembourg. So that's a little bit more reliable, and so things seem to be doing quite well. However, as we saw earlier on the western side, we don't have all of the 10 available. However, when we're looking at this map as a whole, when we saw as the report once it loads up, it's actually saying they're all available, but we know only on this side. So we can change the settings and we can say, actually, we're going to look at half the map and those that are selected. So what I can now do is select a partial bit of the map. Let's do that half. And so now do the assessment purely based on what's on that side of the map. So it's picked up some big groups there, but what we can see immediately is actually only 5 out of the 10 are available in terms of the resources needed for the hoverfly. We can come down the report and it will tell us various things. So what's missing for July, August adult forage. So we'll come down here. So it could well be that we're missing some maybe sown wildflower margins or something, or maybe we could have some different arable crops. Likewise, we can look at some of the other aspects for the pollen as well, or for the larvae. So if we come down to larvae for August, long list because they've got 10 habitats. So it seems to be the particular cropping that's taken place in this case. So I'm not going to go into the details of the report there, but what we can now do again is explore that what if. So maybe we need to put in a margin, a wildflower margin, and maybe change a crop somewhere. So if I come down to here, I know there's already a margin here. So if I select it, this is a margin that already exists, but we didn't actually know what was being grown on that margin, so it hasn't been included in calculation. So if I come back to the feature data, and we can say, actually, let's actually put in a sown wildflower mix on that margin and save that. So we put a little bit of extra resource in there. And so what does that then do for the calculation? In that case, we've ticked the boxes for those first two, but we're still missing the resource that's needed for the larvae in July and August. And we know, as I saw earlier, it's probably the cropping that needs to do that. And so we know there's an area of arable land here. So we could select that instead and say, actually, let's think about what we might put on there that's different. And again, we might be thinking about what is required at particular times of year. So what crop is flowering and when affects the hoverfly. So in this case, I'm going to pick something, maybe sugar beet. Put that on in there, save that. And hopefully what we should find, if I followed my process correctly, is actually now we've actually ticking all the boxes once it does. So now on this side of the farm, we're also getting everything that we need. So if we then zoom back out, I'll turn off my option back onto doing all features again. What we should now find is actually I'll do the optimal zone assessment so we can see that how it's changed. So if we now clear that so we can see it clearly. And if we click that one to keep it clean. So we should now find, so as well as having the optimal zone on this side of the map, by making a couple of changes over here, we're now addressing all 10 habitats needed for the hoverfly with the introduction of a wildflower strip and a change in cropping in one of the fields. So again, it's showing how you can go through the process of understanding not just the strengths and weaknesses on the whole map, but actually saying, I want to focus on this area because that area looks like it's okay. So you don't have to create a completely new project. You can do a quick assessment in there. So that's the main thing we wanted to show with that assessment. Is there any questions in relation to that particular examples? If so, please shout now, or we can always come back to it later. No. Okay. So we'll move on to the next example. So we're moving over to the Netherlands now. In this case, we're focusing on farmland birds. We already touched on grey partridge earlier. So previous examples we've looked at, grey partridge, hoverflies, are in single species or species group focused. We're now going to explore examples of actually, what if your interest is in multiple species? It could be multiple birds, it could be a mix of birds, pollinators, could be pollinators, other invertebrates, whatever your particular interest is. But how do you actually explore that when you're not focused on one indicator? So what we're going to show with this is how you can, there's a mapping calculator tool within the tool within Feast that we can show you. But we're going to quickly run through about, as you can imagine, if you've got 6, 7, 8 species, they've all got different requirements. So Doug's going to briefly explain that behind these particular bird species.
Thanks, John. Going back to the grey partridge example earlier, we've got for these species nesting, forage and overwintering. Some have different requirements. You might notice the turtle dove and yellow wagtail, there's no eggs there, as they are migratory. You might also notice that there is different broods, so corn bunting and skylark. These are species that have been identified as requiring producing 3 broods in order to maintain their population at a stable number. If they're having different broods, obviously they're present within the landscape at different times of the year. Okay. These, for example, corn bunting tends to be a slightly later nesting species. So you might be looking at June through to August, looking at probably approximately 4 weeks per brood. So June for brood 1, July, brood 2, August for brood 3. Now, the management, obviously, the landscape can change during that time. You could have, for example, a winter sown cereal. Now, that might be suitable earlier on in there, perhaps for brood 1. But then it's going to get harvested probably during July, which means if there's a second brood in there, it's not going to be suitable. So broods 2 and 3 won't be able to complete in those areas. So it might be okay for the first brood. So you need to have combinations of different crops, different and uses in combination in order for these particular species to complete their life cycle. If, for example, they're using spring sown cereals, sometimes they can be present in that. That now would be, for example, if you're looking at barley, depending on which country you're in, you might be looking at, for example, harvest maybe mid-August. So that might be suitable for brood 2. If you've got something like spring oats, now that might be later still. So the harvest date might not be until the end of August. Now that, in theory, then could sustain brood 3. So you're having these different combinations of different types of crop that are potentially suitable throughout the cropping season for these particular species, in addition to providing suitable forage sites and overwintering sites, which typically overwintered stubbles. Some species we've focused on just the single brood. This is based on data from GWCT, RSPB, BTO, Conservation Evidence Series. Some of those we focus maybe on all 3 broods, where there's the need for them to complete those in order for the populations to remain stable. The remainder we've focused on just the single brood. So we've just got those 3 parameters: nesting, forage and overwintering. The next slide, please, John. So different species can utilise different habitats. Skylarks, for example, tend to require more open landscapes. So we're looking at arable, grassland and land strips. Other species, there may be more woodland edge species. Turtle dove, for example, might be able to utilise a scrub on the edge of woodlands, or utilise scrub habitat for nesting. But then it will be utilising the arable areas for forage. And something like the yellow wagtail may have requirement for aquatic, slow-moving aquatic habitats within the area, for example, ditches or grassland adjacent to ditches. Okay, so each of them have slightly different habitat requirements. In theory, you could provide all those habitats in quite close proximity to each other, but some of them, they may not be suitable for particular species. So, for example, the skylark, where it needs an open habitat, isn't going to be so complementary with, for example, a tree sparrow that nests in cavities and requires trees in hedgerows. It might contradict each other slightly. So with the spatial tool and the spatial element within Feast, it's looking at, based on their core sustenance zones, where you could position these particular features within the landscape to satisfy the requirements of multiple bird species. Next slide, please, John.
Back to me again. We're taking account of what Doug's just been saying. What we've done is prepared another example. This case, we're at the Netherlands, as I said. So let's open that up. Now, what I've done here, I've already done some assessments for some of those species that, as Doug was mentioning on those slides there. And so we can just have a quick look at these. So we won't necessarily go directly into the map editor. We'll look at the map viewer, which is because that's a quick and easy way of looking at different things. So for linnets in this instance, so if I put the key on, we've already done the assessment, and we can see within this area, which is just to the east of the town there, middle, we can see again the various strengths and weaknesses of this particular block that we're interested in this case for linnets, and we've got a range from 0 up to about 34 in that instance, with some real strengths here and some weak areas on the northern side. I come out of there, and then let's pick a different one to go into, say, corn buntings. Slightly different pattern, but again similar view in that case, where we got some strengths maybe down here, but again fairly weaker on the northern side. Let's go turtle doves. All seems to be around this area here, which with turtle doves, and again if we put the key on, we can see the numbers are quite a bit lower with turtle doves, so not so strong for turtle doves in this landscape. And then what have we got left? Yellow hammers. Yeah, it's quite patchy, but some strengths and weaknesses again in the landscape. Numbers, I think, probably a bit higher. Yeah, a little bit. And finally, the yellow wagtails. Much more coverage in this case, with a few pockets where it's stronger than others, but quite a few providing habitat across the board really there. Now, those are individual assessments for each species. So how do we think in terms of understanding the strengths and the weaknesses in the landscape of whole across all those species? Well, what we can do is actually use the map calculator function, which is common in many GIS type tools really, to try and combine them all. So I'm just going to open up a slightly different map. Let's open up that one. So I'll come back to the spatial metrics tool within the software. So we got various things here. We did do assessments for some of the other species, but they had fundamentally missing habitats for some of those. So certainly corn buntings, curl buntings was missing some, skylarks were also missing relevant elements for breeds 2 and 3, as Doug was just talking about a few minutes ago. But what we can do in terms of this particular example is use this map calculator function. And so it's simply a case I want to say add up everything for everything we have done an assessment for, so yellow hammers, and we'll also do the wagtail. And we got some preset equations, so I just want to add them up. And what we can now do is say, okay, you're going to add those all up for me, and then we can see what that looks like across the landscape. So we click the calculate button, that'll just crunch away, doing some sums, and then put them on the map for us. So what we've now found is actually summing up across those 5 species. We've quite clearly got some very strong pockets around here in the west, and also a bit further over here in the east, and with a mixture in between. So it's given us an idea for across all 5 of those species, where is the landscape really delivering for all of them, and where is it perhaps only delivering for 1 or 2, taking account of some of the things that Doug's just been talking about in terms of their individual requirements. It'll then be a case of saying, okay, well, perhaps in some of these weak areas, what is it that's missing for some of those species that perhaps is being addressed for others, but not for those where it's weaker. There may well be instances where you do have trade-offs between species, and so you don't want to change it for one at the expense of another. And so that is a tricky thing to get right. And that's something that maybe we might explore as we go forward to see if there's a way to say actually really explicitly highlight those particular attributes of certain features where actually we'll deliver for both or where there is a trade-off. So it can get a bit complicated. But just as a basic, simple calculation tool, this shows how we can start looking at multiple species rather than just one. We'll press on. If there's any questions on that one, please do shout out or raise them at the end. In which case, if there aren't any questions now, we'll press on to the final example, which is moving down into the south of France, probably a bit warmer. This one, we're going to focus on butterflies, the nymphalids in this instance. You'll see in a minute, this is a much bigger geographical area in terms of the cluster we're looking at. It's got a mixture of orchards, more conventional intensive orchards, not traditional ones, vines and arable cropping. Now, the purpose of this example is we actually only generated this just based on land use land cover maps that were provided to us. So we haven't been down on the ground. It's had a little bit of input from the cluster advisor, but not a huge amount. But it's just showing you how potentially you can set something up using imported data that already exists. So you can set things up and do quite rapid assessments to get the data in, because as you can imagine, the more data you put in, the more you get out of it. So if there's an easy way to zap the data in, you can do. But it does present some additional challenges, which we'll highlight with this example. First of all, I'm just going to hand over to Doug again to explain the thinking behind what's required for this particular group of butterflies.
Thanks, John. In a feast, rather than treating species, we've not got lists for individual species here. They are grouped based on citizen science classifications, based on the generic output here: blues, browns, coppers, fritillaries, nymphalids, skippers. Fairly general classification here, but what I've done is we've reviewed in detail the forage that the adults will utilise, any preference for particular flower species or groups of species, and any particular preference for the larvae when they're feeding for pupation. That can be more species specific in terms of their preferences. Using habitat suitability approach, we've assigned those as of no value, suboptimal, or optimal. So I use this example, the nymphalids. And there's a couple of species here of interest, depending on where you are in Europe. So it's large tortoiseshell, small tortoiseshell, and comma. So of these three species, there's general preference hedgerows with species such as blackthorn, willow. Bramble is quite a ubiquitous one in terms of butterflies. Pollen and nectar mixtures that contain multiple species from the larvae. Of those that are present in a cropping environment, or likely to be present in a cropping environment, this large tortoiseshell can utilise the leaves of pear. The comma can utilise red currant and black currant, so it might be orchard species. Then also species that might be present in, for example, hedgerows or even agroforestry plantations, wild cherry, or the willow. And lucerne can be utilised. Next slide, please, John.
It's back to me. We're going to go off to south of France, and that's where I'm going on holiday next week, which will be nice. This is a much shorter example, but demonstrating a couple of points. Let's load up that one. What we can do, let's open up that one there. We've already done the assessment for the group 3 nymphid butterflies in this instance. It's a much bigger area. What I'll do is I'll change the base map. There's various base maps that you can utilize within the tool. I put the OpenStreetMap on because that makes things clear in this instance. You've got various base maps you can have here. We've got OpenStreetMap, we've got Esri World Imagery, we've got Bing Maps. Till the end of this month, unfortunately, Microsoft are withdrawing Bing Maps to everybody unless you happen to have an enterprise license for coming years. That's a shame, but they're available for now. And if you do have an enterprise license, you can continue to use them. There's a topographic map, and there's all the Sentinel maps going back to 2017, which are lower resolution, but more up to date. As you can see, changing the base map in some instances makes you able to see things more clearly in terms of the strengths and weaknesses in the landscape. Excuse me. We can put the key on to see how the numbers are. So we got quite a few in the mid-range, about 60 hectares there, but it's even spread across the different ranges there. As I said, this data was drawn in from a land use land cover map through an import process that we've got in the tool. I won't demonstrate that, but we got the two halves of the cluster here. We've got a group down here. We can see some strengths and weaknesses across the landscape there, and similarly up here. And we can see some dark areas here. Interesting, if we zoom in, we can see what these are. It's hedgerows that are scoring highly and performing well in the landscape. But there's a big but here. When we started looking at this, and we found perhaps what we defined as a hedgerow was slightly different to what they define as a hedgerow down in this location. What we can do is a function within the software where if you come up to the map here, you can open up the current location on the map within Google Maps. We'll do that. And what we'll be able to do, if I close that, is use your good old Google Street View to have a look at these hedgerows on the ground. Let's move around. If I come into the right place, probably not. Let's come back a step and move up. Move up to there. No, I've misplaced my location. Here we go, that's better. I was guessing there. We can see what they're defining as hedgerows are coniferous windbreaks, and which is substantially different to the description of the hedgerow Doug had open a few minutes ago. And what we've learnt from that is what if we come back to our assessment here, many of these are these coniferous hedgerows and windbreaks, and probably aren't providing the habitat for the nymphaliid group 3 butterflies. We need to adjust the assessment for that landscape feature to take account of the fact in certain locations you will have conifer hedgerows which are still native, but which aren't delivering what's required for that particular species. As much as we've been learning with the grey partridge example for earlier, in this example, we've learned we need to have a more definition on what defines a hedgerow in certain locations to make the habitat suitability assessment more appropriate for that location. It's demonstrating how we can use tools within Feast here to explore these issues and highlight where the relative strengths and weaknesses are in the landscape, in this case for butterflies. If I flip back to the presentation, that brings us roughly on time to the end of all the case studies. We've got about 20 minutes for any general questions and answers, and we can have a panel discussion. Theo has potential prompts for us if we want to explore those. Probably heard enough of me talking, so maybe some others would like to talk now.
Thank you very much, John and Doug, for a very clear presentation with lots of rich detail. While that's fresh in people's minds, we should open the floor to any initial questions, and we'll dive into our panel discussion. If there are any questions from the floor to kick us off, do feel free to raise your hand. Thank you. Hopefully that's a good sign, because it's been so understandable that there are no questions. I'd like to thank everyone for being here. Over 100 people signed up, but these days most people are interested in the webinar recordings and the slides. The group who have attended are a select few who will get to contribute, and the discursive aspect of this topic is hugely important. So to introduce myself, I'm Theo from Tarscape Associates, which is a knowledge exchange partner on the Framework project. And I'm going to be Out of Vision moderator for this informal open panel discussion. The prompts or the questions revolve around two key areas. The first area is a practical discussion of the tool, reflecting on what we've heard from John and Doug today in terms of implementation, usability, use cases. on the ground. As part of our work on framework, we've interviewed over 200 stakeholders over the course of the project, and many of those have been farmers and land managers. Clearly, speaking to both control farmers and farmers involved in the biodiversity measures on framework, there's clearly a lot of interest out there in leveraging the information that FEAST can provide. That is for various purposes, including managing functional biodiversity through natural pest control, or looking at big picture things like agri-environmental schemes and conservation programs. The key thing to reflect on is that requires two things. It requires engaging with agri-tech orientated farmers, but it requires this advisory role. I'd love people to reflect on that advisory role, whether it's human through NGOs, cluster facilitators, or government advisors in those parts of the world where those jobs still exist. Or indeed, if it's AI. The project saw interesting examples last year at the Ecosystem Services conference, partnership conference, where AI is being used as the middleman, the advisory middleman, to surface some of this information for land managers. Then we're going to zoom out and think about the bigger picture. And we're lucky to be joined by invited panelists from the UK's Joint Nature Conservation Council, the JNCC. I would love to introduce to you Rory and Hannah. Rory is a senior analyst at the JNCC, and Hannah, who may also contribute, is a senior advisor in land management and biodiversity. We're lucky to have stakeholders of different types on this call, and we thank you for being here. That includes the Massachusetts Department of Agriculture in the US and organizations from South America, Europe, and elsewhere. After our panelists have contributed, we would love to hear from you. The focus of that bigger picture section is to look at how spatial approaches and tools like FEAST can help regions and nations with their sustainability and conservation goals. And that includes their contributions to international agreements. To kick off the discussion, John, Doug, Rory, and possibly Hannah, the first question is how spatial habitat suitability approaches within FEAST fit within existing approaches to habitat enhancement and creation. Is the level of sophistication too great? Is it too granular? Or is it too superficial for practical use? How applicable is the approach presented in today's webinar to different regions of the UK and Europe and indeed the world? If any of our panelists have some initial thoughts on that, I'm sure the group would love to hear them. Thank you. John, I remember we've discussed a few times the way spatial tools and approaches are of interest to cluster facilitators, NGOs. I know in the Czech Republic that Czech BirdLife had engagement with the cluster. I know that you work with JNCC and organizations like JNCC in your broader activities. How do you see that question of applicability of FEAST within existing stakeholder interests and existing schemes and contexts on the ground?
I don't know is the answer. Yeah, no, we've designed the tool to be pretty flexible in terms of the level of detail you want to work at. And I didn't show it in the demonstration, wasn't enough time, but the way you can work at different levels. So you could work right down at individual field level with defining very specific small areas. And that may well depend on what your objectives are. If you're very interested in those species which don't move very far, and so you want to see that level of detail in the habitats in a specific field, you can do that. Same time, if you want to do something bigger for maybe bat species which travel several kilometres, you've got to come up to a much higher spatial level to actually look at that. And potentially what you can do is work at a lower resolution to start with, and then you can group the outputs off that assessment into a single shape file, because ultimately the system is resource limited. The more shapes and the more calculations, everything you have to do, the slower and slower it will get. And that's the same with most GIS systems. But if you then group things together within that landscape or within a bigger spacious scale, you can say for that cluster, the attributes for that or for these particular bat species is X, Y, and Z in terms of the importance of that habitat and that landscape. And for this one over here, it might be lower or it might be higher. And then you can treat those groups, those clusters or features as single entities in that larger scale assessment. That's a cruder assessment because you're not looking at the intricacies of the individual features, but in terms of the larger landscape assessment, you can do that. So it's a question of what your purpose is for using the tool and what scale do you want to work at. So as I said, we try to keep it as flexible as possible because we recognise that different end users have different requirements, ranging through from doing very simple calculations. You don't even have to use the mapping tool. Go in and assess your hedgerows using the land and feature manager to give you an assessment for habitat suitability across different species, or you can do the full thing and import shape files, allocate data to them, and do some big number crunching to see how that all works. Now, how that aligns with how other people operate, I'm not necessarily the best person to answer that. So I certainly welcome any other perspectives on how other people operate in terms of doing landscape scale assessments. Unless you want to, sorry, please go ahead.
I was gonna jump in there, but Rory's got his hand up, so I'll hand that over to Rory.
Thanks, Hannah. Yeah, John's absolutely right in that it depends tremendously on the use cases, the individual requirements that people have and the purpose that you intend to use this information for. I definitely echo all of that sentiment. And I think if we're looking at and thinking about some of the challenges in terms of using this source of information and these tools, I do think a lot of it comes down to accessibility, or I think that's a very key consideration to make. And I can definitely see value and applicability in some of what's been presented today in a lot of circles, but I think one of the big challenges will be, if directed at more of the farm manager level, is the ability to use software and simply have the time in order to actually undertake some of these assessments and really work out at a land parcel level what is right for an individual. So I think it's very exciting, but it's a challenge that we all face in the community as to how do we actually get this translated to the ground and getting people using them. But Hannah, do you want to come in at all?
I was just going to strengthen what you've just said there, Rory, about treating farmers, land managers, practitioners, advisors on the ground as a monolithic blob. Actually, there are different types of users, and being clear on, I think that's somewhere that the community definitely, as you alluded to, Rory, we're trying to do it to the best of our ability, but I think we would need support in it, is trying to think about the different categories of farmers and the different categories of land managers and what decisions that they are making and how different tools are suitable to those different decisions. I'm sure most tools can help with different kinds of decisions. It's not to say there aren't multiple benefits or multiple impacts, but yeah, I think that is the challenge, is specifically tailoring tools to individual groups rather than seeing farmers as a monolithic blob, actually breaking that up and having a common language between tool developers to try to understand that, to share that, so that we're helping those we're trying to encourage to make decisions to understand when a tool may or may not be appropriate.
Yeah, the language issue is not just an issue within English-speaking countries. It is also across European countries. We were certainly having that last week in the one in the Czech Republic, where the idea of conservation headlands, had to explain what that was. Once they explained what it was, they understood the exact practice of what it was. They saw, oh yes, we just call it something different. So that exists across borders as well. Yeah.
Thank you very much, all. So the visual aspect of Feast is probably one of its most innovative and accessible elements. The way that you can, for example, John, you often say that if you can use Microsoft Paint, then you can use the biggest picture aspect of Feast to look at the habitat modelling. And indeed, if you are one of those advisory figures that Hannah mentioned, you can show that to farmers and land managers in a way that's quite accessible. So I wondered whether our panelists and anyone else had reflections on how accessible graphical visualizations of all this complexity can be useful. Obviously, there are also risks involved, I'm sure, but how can these be used and improved on going forward when we look at the future of spatial approaches with these stakeholders? Obviously, keeping in mind Hannah's point about context being really important with that as well.
I'm happy to take that one first, Theo. So this is the information I have for English farmers. It might be appreciating the breadth of people on the call, but for English farmers in particular, we know that there are higher levels of neurodiversity. And in particular, I think dyslexia the rates of dyslexia are higher amongst English farmers than the general population. And I think one of the findings that we've heard about is around that and how the use of visual information could be a more effective way of communicating priorities than lots of text heavy information and things like that. So I think that is another angle to consider in terms of the spatial element, in terms of, yes, all of the inherent biological nature of spatial responses in ecology and biology and natural capital and ecosystem services are by default very spatial. But on top of that, actually thinking about the users, if that's not a too coarse a word to use, the users of these tools and what their specific needs might be, and if there are specific neurodiversity features or accessibility needs that different groups might have. I'm thinking on the flip side of that, if you're in areas with poor rural broadband and things like that, having tools that are accessible offline is important. Having tools that don't demand too much internet bandwidth to access it, which spatial features can sometimes have. And John, as you've just alluded to there in your previous response, the time that it can take to process these big spatial maps. And I think one of the strengths of a cluster-based approach is that perhaps some of that burden could be either shared or taken on by a lead advisor. And I think that's a role that we're quite interested in exploring, is trying not to overburden the people you're trying to help by presenting them all of the possible information and actually helping them understand the maps and things that you've got and what information do they actually need to understand that. So it's not something that we've perfected, but I do think accessibility from a who your end user is perspective, both from a neurodiversity, but also just a logistical, can you access it on your phone? Is it going to download over your Wi-Fi if you can get it where you are? Is it over satellite Wi-Fi that's throttled or something? So those practical limitations come into it too. But I think it's clear that the nature of the environmental features that we're all trying to improve or manipulate or take action on are spatial by default. And so I think it is an area where common community progress could help with that.
Fantastic. Thank you. I'm just going to zoom back into the detail for a second. We've had two very good questions from the floor. And thinking about those environmental factors that Hannah mentioned, when looking at FEAST's ability to consider functional biodiversity and the habitat that supports that, there are existing tools that support farmers mapping pesticide use, and a very few of those include biodiversity considerations or pollution considerations. And our project's been working with Syngenta and a few others to explore that. But just to dive into those aspects of the detail offered through tools like FEAST, what would you say about the incorporation of not just habitat mapping, but organic and conventional pesticide use mapping as part of FEAST, or indeed going in the other direction and seeing how FEAST could inform existing tools in that space, particularly I'm thinking of advisors and very agri-tech orientated farmers who may be already using tools like that and be familiar with them. And then another aspect that has been raised is the applicability for medical and hygienic research. And I imagine perhaps the angle on that would be human contact with wilder areas, perhaps not so applicable to the UK and Europe, but certainly other parts of the world where the approaches FEAST are taking can be presumably quite insightful for human-animal contact and the various environmental factors around that. So, yeah, I'd love our panelists to reflect on both of those if you have takes on those. Thank you.
To On the add-in on the pesticide side of things, we are in the process of implementing a new indicator in the FEAST tool, which allows users to calculate a pesticide load index. There's two indicators, one which is the UK pesticide load index, which we've been working on with DEFRA on developing. We allow farmers to do a farm level calculation for that, but also we're working on implementing a total applied toxicity index as well, because that's going to be part of the reporting for conventional biodiversity as part of the global biodiversity framework. So they're fairly crude metrics for assessing environmental impact of pesticides at a farm level, because you can do something far more sophisticated. But at the same time, they're relatively simple. It's listing pesticides applied and amounts used at different times a year, and that's it. We've got a prototype up and running for that, which will allow people to see spatially where the pressure is in regards to pesticide use, and then that also then gives us the functionality to take account of that within in any particular habitat suitability assessments, for example, for pollinators, parasitic wasps, things like that, things which can be impacted upon by pesticide use. We can then make use of those assessments as part of the habitat suitability assessment. It's not there yet, but it's something we would like to do. That's where we are with that. I thought I'd throw that in for starters.
Maybe, Theo, I can take on the medical or back angle. From a JNCC perspective, the area we're interested here is about identifying trade-offs. We know there are benefits from improved human health, increased well-being, increased physical activity. We know there are all of those benefits from increased recreational time in nature. That's on the pros side of the table, if there is a table in my head. And then on the other side, you have all of the increased exposure to things like Lyme's disease through ticks, or with changing climate, things like mosquitoes. From our perspective, what we are particularly interested in is the ability to make those trade-offs. Can you quantify the benefits? Can you quantify the risks? And then ultimately, what we would see is that's where you start moving towards more of a political judgment. Is it overwhelmingly obvious that the benefits you get from increased recreational, increased time outside are particularly stronger than the increased risks, and the impacts on for the exposure to pathogens or things like that would be around the cost then to the health service, and can we quantify that? And we're quite interested in trying to use a natural capital approach to quantify the pros and the cons, or the implications of those decisions. And that's where we're particularly keen to see long-term academic partnerships to really try to address some of these consistent problems. It would be interesting, and that perhaps this is where I don't know so much about FEAST, but it would be interesting to see how those trade-offs would be able to be built into any tool that considers that. Part of it is ultimately then the ability to take those farm level insights and take them up to a more regional or national picture, because that's where you will be able to say things about the impact on the health service. That's where we think a more regional or national natural capital approach would be particularly useful.
Thank you, Hannah. And in case we didn't capture the meat of the question being asked on medical and hygienic research, I would imagine that another angle on that would be nutrition. Again, a bit like pesticide use or chemical input use, it's yet another aspect into what is already a very complex picture. But I wonder whether aspects like crop quality and value for nutrition are also of relevance here when we think about FEAST. I know that the farm advisors and cluster facilitators and indeed more conventional farmers I've spoken to identify strongly with the issue of farmers seeing their main role as providing high quality crops, with all the knock-on effects for the conventional practices that they see as key to that. Does anyone have any reflections on that, the nutritional aspect, when it comes to looking at a tool like FEAST?
The whole topic and area of food production is a really crucial consideration and trade-off that does need to be considered and factored into some of these spatial tools when looking at what sort of actions you should do where and how you might achieve certain ambitions and objectives for different environmental targets. And it's something Hannah mentioned in her previous response that we're very interested in looking at. It's all well and good to look at it purely from an environmental data perspective and what makes sense environmentally, but there are also realities of the world in which we live in terms of economics, in terms of food security and all these other factors and considerations. And it's something I don't think I've come across a tool which is fully able to have brought those things together and actually make that clear comparison and trade-off and provide that additional information. It's really important to do, but quite difficult to do as well, because you're looking at different measures and different metrics, and pairing the two is challenging.
Absolutely, I would concur with that. To some extent, we can cover it a little bit with the signposting. So if people are interested in particular options that are being offered up as potential solutions to increase environmental benefits, it's then signposting them to the information or the guidance which says, actually, if you're going to do this, the cost of doing that is X, Y, and Z, or the implications are for the business. Because to try and do that on top of everything else within a tool like this, it's another ball game altogether, and we certainly didn't have the resource to do it. And there are probably better tools out there for doing that thing. And it's about understanding where things are being done well by existing resources and existing tools, and then the issue is interoperability, making sure that actually if the data is entered in one tool, it can transfer to another, and vice versa. And that's a key challenge across the industry in multiple aspects of handling data and information, and not just this particular case. But a number of people, as we've been going along, have suggested you give us an economic assessment of those different options as well. Doing that in one country is hard enough, then trying to do it across 27 other countries in Europe, you're into a complete minefield of getting the data and the numbers and the calculations, which will all be different in different locations. It's very difficult indeed, as you said, Robbie.
Thank you. This leads us nicely towards our big picture final questions. But on the way, as we travel to those, do our panelists or any others have any reflections on the trend around what you're describing? Within Europe, I know that last year there was an agreement called the DeSantis Agreement, which aims to create better data management across Europe and data accessibility, and also prepare that data for usage by AI. And the data in question is the data that is being used within FEAST. And indeed, GBIF and some of the things that have been mentioned today. I know that at our conference a few weeks ago, a consortium from India attended, who are currently undertaking a process through a project called AIMS to prepare biodiversity and environmental and landscape data for AI usage across the whole of India. As panelists, do you see a positive trend when it comes to the possibility of what Hannah and Rory and everyone have been describing, for flotillas of tools that are useful in different contexts to be drawing on bigger pools of standardized data, and for the context to be beginning to support that? And what are the barriers and opportunities we travel in that direction?
Theo, I'm happy to take that first. One of the things we're trying to do is look at the tools out there to understand their interoperability. We've done a recent tools review where we looked at a range of tools that considered prioritizations that took individual targeting of different actions and then compared them against each other. And we tried to review the methods that they used to do that. And we can share a link maybe in the chat, or someone can put a link to our website where we will hopefully be publishing it soon. But beyond that, a lot of the work that we are doing around modelling is trying to understand that. Maybe I've posted a link in the chat to the ERAMP programme in Wales, which people may value a click around in terms of you called it a flotilla of different interacting data there, Theo. What Wales have got in ERAMP is a very strong modelling programme that's being used to influence policy. And that shows you that there are soft coupling ways of doing that. ERAMP is the UK example I can think of off the top of my head that is particularly strong. We would value more long-term conversations with people. Would be interested, Theo, to hear more about the group that you were doing, said were doing it from an Indian perspective, to see their methods, because it is a challenge, and I don't think we've quite grasped the full scale of the challenge. A slightly inadequate answer from me, Theo, in the sense that I don't think we have the answer, but we're quite keen on trying to find out more about it.
Fantastic. And some of this work is being done in relation to regions and nations' priorities around the world, but also international agreements. It would be amazing to close on perspectives from the panel and the floor on how people see tools like FEAST contributing all the way from a regional perspective to the ability of nations to contribute to and make progress towards the aims of international agreements and evolving trends.
It's a very big question. I mean, I'm in a little bit of an advantageous position, so I'm dealing with both ends of it anyway. And you do see the connections, but I don't think those connections necessarily are there in all the way through. In many other cases, there are stepping stones which individuals are involved with on each of the stones, and they're not necessarily dealing with the whole chain of data from top to bottom. But it also does tie in with the whole interoperability and the types of data that are being generated, and how is that then utilised, not just in its original intended use case, but in terms of other use cases and where it's relevant. Because that's what, in the past, is why we end up with a very fragmented data ecosystem. In fact, everything's being developed for very specific purposes, and quite rightly so. But then when we want to construct a bigger picture, sometimes it's done in slightly different ways, sometimes done in completely contradictory ways, and then give us cross wires in terms of the picture it's presented, or contradictory pictures, which doesn't help. So there does need to be a little bit more joined up thinking from the farm level to the UN level on how this data might be used better, or used at all in some instances.
John, just to echo those messages that you've just said, I think it is the challenge that we're all trying to tackle, is considering the farm level to the cluster level, to the local level, to the regional, to the national, to the international, and the core thread of evidence that cuts across that will be particularly important. And I think it will be a new challenge for academic and policy partners to work together to identify what that core thread is, and what data at an international level might look like around pesticides, and then at a farm level does that echo. And I think we're interested in the creation of these indicators for the big multilateral agreements that we sign up to as individual countries, how we can do that. So I think it's another thing to watch out for, but absolutely agree with the sentiment. And just to reinforce that, it does feel like the trend is to use that information, use the data that we hold increasingly to make decisions. And so tools like FEAST and the plethora of others are going to be a cornerstone of those. And what we will absolutely need is the partnership with the creators of tools to work together on identifying how they link together, and that will require, it will require a continuing collaborative approach, and fora like this are particularly important for that.
Thank you very much all. I can see a few people writing things in the chat. So this is a big conversation that will continue in all our different organisations and at all the different levels. So thank you very much.
Yes, thank you. Thank you for listening.
Thank you.